Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. Enjoy! Just like when you're simplifying fractions, you can't have decimals at the top and bottom. You can't have decimals at the top, at the left and right of a ratio. So we're going to have to get rid of this decimal. And the way we're going to do that is just simply times each side by 10. And that will leave 4, and that will be 60. Now we can simplify this further, because I can divide left and right by 2. So that would be 2 to 30. And I can actually do the same again. I can divide them by 2 again. And that would be 1 to 15. Now you might have just divided by 4, and that would also give the right answer. In fact, there's a couple of different methods that you can get the same answer with. So we've got to first of all work out how many parts there are altogether. So we're told that the ratio of red, yellow and green is 3 to 2 to 4. So to work out how many parts there are altogether, we do 3 plus 2 plus 4, which is 9 parts. So there's 9 equal piles of sweets. Okay, but to work out what one part or one pile of sweets is worth, we're going to get the 99 sweets and divide it by the amount of piles, and that's going to be 11. So one part is worth 11 sweets. We're asked to find out how many yellow sweets, and yellow is the middle one, so it's going to be the 2. So yellow has 2 piles of 11 sweets. 2 times 11 is going to be 22, so it's going to be 22 sweets. So we know that 171 is 3 times 3 times 19. And what we do is we just compare 171 with 342. And we know that 171 times 2 is 342. So therefore 342 will have the same prime factors as 171, which is 3 times 3 times 19, but it will also have a times 2 in there. So the answer will be 2 times 3 times 3 times 19. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets. And we don't need to. We could divide both sides by 7, but I think this is a bit easier. And we're going to subtract, or we're going to add 70 to both sides. So we're trying to get x as the subject. So we're trying to get x on its own. And we're next going to divide both sides by 7. So we have m plus 70, all of that over 7 equals x. So x equals m plus 70 over 7. We're going to first of all have to convert these both into the same unit. So we've got minutes and hours. That's not going to help us much. So what I'm going to do is pick the smaller unit, which will be minutes. So I'm going to keep that 50 minutes. And I'm going to convert 3 hours into minutes. That would be 180 because we times by 60. And I'm going to just remove the minutes now. And I can first of all divide by 10, and we want to try and make it nice and simple for ourselves. So divide by 10 would be 5 to 18. And we look at it, 5 and 18, actually there's nothing further we can do with that. So the ratio would be 5 to 18. So when we say y is directly proportional to x, what we mean is whenever x doubles, y will double. Whenever x halves, y will halve. Now we've got this proportionality sign here. And to make that an equals, all we need to do is introduce a k constant to the right hand side. So it's y equals something times x. Now to find out what that something is, to find out what that constant is, what we're going to do is feed in the value of y and the value of x that we have. So we're going to feed those in. So y is 55.3 and x is 7. So it would be 7k. And we're just going to put our lines in and solve this. So it's going to be divide by 7 both sides. And 55.3 divided by 7 is 7.9. And that's what k is. So we're going to rewrite this equation here, this formula here, y equals 7.9x. And that is actually our answer. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got two sets of parallel lines here and here, and a line going through them. And we kind of got these f angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78. And we must write down the reason, so corresponding angles, and corresponding angles are equal. Now here we've got an equation and we want to solve it, so we get our lines in. We'll go first of all, add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also two parallel lines, and we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180, angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. So we know that James knows that he has a square. So we can actually get rid of all of this bit. It's not relevant at all to the question. And the question asks, what is the probability that the square is blue? Well, there are 3 blue squares, so it will be 3 over, and how many are there in total? Well, it says the total is 17. So the answer is 3 over 17. So the symbol here basically means and the way I remember it is if you draw that symbol and just put a line through it, you can make the word and. So we're looking at the probability of getting something that is in A and C. So the only ones that are in A and C are this 8 and this 9 here. So we're going to just add the 8 and the 9 together, which give us 17. Now we need to then work out how many numbers there are in total, so that's all of them. So 4 plus 8 plus 9 plus 5 plus 8 plus 3 plus 11 plus 6. So we need the total, which is 54. And then we get the 17, and we put that over the amount in total, so over 54. The key to estimating is that normally you will be rounding numbers to one significant figure and then working out the answer. So I'm just going to rewrite this fraction here, but instead of 93, we're going to round that to one significant figure, so that'll be 90. We're going to round the 265 to one significant figure. Now, some people will write 270, but one significant figure means the line goes after the 2, and so that would round to 300. Then 31 will round to 30, and 97 will round to 100. Now the next step is to see things that we can cancel here. So we can divide top and bottom by 10 to make that a 9 and make that a 3. We can divide top and bottom by 100, make that a 3, make that 1. And we can divide top and bottom by 3, so that will make that 1, and that will make that 1. And so at the top we've got 9 times 1, which is 9, and at the bottom we've got 1 times 1. So 9 divided by 1 is just 9. So our answer will be 9. So we're going to start by understanding that all lines form or can form an equation y equals mx plus c, with m being the gradient and c being the y-intercept. It says here the gradient is -2, so we've already got a bit of a head start with this, but we don't know what the y-intercept is. So we're going to use this first set of coordinates to work out what the y-intercept is. So y is -31 and x is 15. And we're going to use this to solve and find out what c is. So first thing I'm going to do is, well, just tidy this up. 2 times 15 is 30, so -30 plus c. And I'm just going to add 30 to both sides to get c on its own. So that would be -1 equals c. So c is -1. So we now know that the equation is y equals -2x minus 1. And we're told that the y is -37. And we're looking for the x value, which they've called w. So let's get our solving lines in. Okay, so the first thing I'm going to do is add 1 to both sides. And so it would be -36 equals -2x. I'm going to now times, or divide everything by -2. And a negative divided by a negative is positive. 36 divided by 2 is 18. And then obviously that gets rid of the coefficient of the x, so it's just x. So x equals 18. So the x value is 18 and the x value is the w value. So w is 18. To subtract mixed numbers, we must convert them into improper fractions first. So to do that, we do the big number times the bottom and add to the top. So it's going to be 3 times 4, which is 12, and add to the top, which is 15. Keep the bottom the same. 2 times 5, add to the top. So 2 times 5 is 10, add to the top is 11. Now we need to get the denominators the same. So the first number in the 4 and the 5 times table So we just write out the times tables and we can see that 20 is the first number in both of them. So we're going to times top and bottom of the first fraction by 5 and top and bottom of the second fraction by 4. So we must have the denominators the same to be able to add or subtract them, in this case subtract them. So when we do that, we get 75 over 20, and 11 times 4 is 44 over 20. Subtract the tops and we get 31 over 20. This is improper, so we can take away one lot of 20 from the top, which will give us 1 and 11 over 20, and that is actually our answer. To divide mixed numbers, we need to convert them to improper fractions first, and to do that we just do the big number times by the bottom and add it to the top. So 2 times 5, which is 10, and added to the top, which will be 13 over 5, and the bottom, the denominator, stays the same, divided by, and we're going to do 1 times 2, which is 2, add to the top, and we get 3, so it becomes 3 over 2. Then we're going to keep the first fraction, flip the second fraction, and change the sign, so it becomes 13 over 5 times, and then we're going to flip that, so it's going to be 2 over 3, times the tops would be 26, times the bottom, which would be 15. Now 26 over 15, there are 1/15s that go into 26, so that would be a big 1, and that leaves a remainder of 11, so it would be 11 over 15. So our answer would be 1 and 11 over 15. So to find the area of a rectangle, we do length times the width. So here, to find the area, we will do the 10 times the whole of the 10t plus 4. And to show that we're doing the whole of it, we put it in brackets. So a different way of writing that is 10 brackets 10t plus 4. And whichever method you use to expand brackets, feel free to do it here. I'm going to just do the grid method, but whatever method you prefer. Actually, I don't need the, I've done too many here. Let's get rid of that. So we've got 10 times 10t plus 4. So and we're timesing them. So 10 times 10t, 10 times 10 is 100. So it'd be 100t. 10 times 4 is 40. So our answer will be 100t plus 40. To answer this question, we need to know what an equation, expression, formula, and identity is. So the formula is basically an equation, but for real-world things. So area equals pi r squared. It's where the letters actually mean something. Expression is just algebra without the equal sign. So 5x plus 3 would be an expression. An equation has an equals and it can be solved, so you can find out what x is or find out what a is. And an identity is true for all values of that letter. So an example would be x times x equals x squared. That's an identity because that's true for all values of x. So looking here on the right hand side, we've got 3x plus 2x. But if we imagine x is 10, so 3x would be 30 plus 2x would be 20, 30 plus 20, well that will equal 5x, 5 times 10. And actually this is true for all values of x. And the reason it's true for all values of x is we know that 3x plus 2x, this right hand side here, equals 5x. They're the same thing. Now normally with an identity, it's shown with 3 lines. Now, in the exam, this type of question, it won't be shown with 3 lines because that kind of gives it away that it's an identity. But this question is definitely an identity. And you can't solve it because it's true for all values of x. So yes, x could be 10, x could be 1,000,000, x could be a third, x could be anything. What I'm going to start off by doing is rearranging this equation so that it kind of matches this one. So I'm just going to write it down. And we want the n to be minus 2. So what I'm going to do is I'm just going to put my rearranging lines in. And we're just going to add 10 to both sides. Now, we've already got this line drawn for us on this graph. And so all we need to do is draw this line. So we've got y equals 10x squared plus 8x minus 2 drawn for us. We just need to draw this line, which is y equals 10, and see where they cross over to find the solutions. So y equals 10 will be all the way up at the top. Let's just make sure I get it nice. There we are. I need to move that up a little bit. There we are. And let's read off the values that that gives us. So it comes down here and it comes down here. So the values it comes down to are minus 1.6 and 0.8, and those are our solutions. So the way this formula works is we have m, which is the final amount, the 2000 here is our initial amount, the decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says what is the interest rate of the bank. Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. First thing we notice is that there is a square here, so we can work out what this length is going to be. It's also going to be 40 centimeters. And whenever we're working out the area of a shaded area, we're normally working out the area of two shapes and subtracting one from the other. And this question's really no different. So we're going to start off working out the area of the square. And all we need to do now for that is 40 times 40, which will be 1,600 centimeters squared. I normally only put units in our answer. The next thing we're going to do is work out the area of the circle, but to do that we need to work out what the diameter of the circle is, and if you notice that the diameter of the circle is just 40 degrees. It's the same as the width of the square, or height of the square. So if the diameter is 40 degrees, the radius would be 20 degrees. So for the circle, for the area of the circle, we're going to do pi times the radius, which is 20 squared, and 20 squared would be 400, so this will be 400 pi. This question's asking us to leave it in terms of pi, so we're going to do that. Now next we're going to work out the all of the corners, so that includes these three here and this one. So I'll say, like, I don't know, 4 corners. Just try and explain to the person marking my exam what I'm doing. And to do that, we're just going to do the square, take away the circle. So 1,600, take away 400 pi. Now we can't actually do anything more than that. That is our answer. So it's just, we just leave it at that. And to work out just the shaded bit, which is this bit here, they are 4 equal amounts that we've got for these corners. So just one corner, which is the shaded bit, will be the 4 corners divided by 4. Now we've got a kind of fraction here. We can divide all of the terms by 4. So that will leave 1 at the bottom, 100 pi here, and this will be 1,600 divided by 4 is 400. So we're just cancelling the fraction, and actually we leave it as 400 minus 100 pi, and that indeed is our answer. You can't simplify that any further. There are a few different ways you could answer this question. I'm going to do it with a tree diagram, but you didn't need to draw a tree diagram to answer this question. So we've got our first tree, which is our first bus, and the choices are male and female. And we've got our second kind of branch, I suppose, and it's still male and female. And this is our second bus. So the property of male on a first bus is 9/15, and therefore the property of female is 1 minus 9/15, which would be 6/15. Male on the second bus is 7/15, and so female would be 8/15, because they need to add up to 1. And it's independent, so these will be the same. And the question is basically asking what is the probability that both will be female. So to have both female, we need to have gone down this line at the start and then this line again. Okay, so looking at the fractions along the way, it's 6/15 and 8/15. The word "and" in probability means times. So whenever you're finding the probability of getting to an outcome, so this outcome will be FF, because they're both female, you are multiplying the fractions that you go across. So it would be 6 over 15 times 8 over 15. So 6 times 8 is 48, and times the bottoms, 15 times 15 is 225. Now you can actually cancel that down. So what you can do is you can divide top and bottom by 4, and that will give you 16. Is it 4? No, you can divide top and bottom by 3, and that would be 16 over 75. So either 48 over 225 or 16 over 75. So this question will probably need a Venn diagram just to make it a bit easier. So I'm going to draw a Venn diagram. You don't need to. If you can work out how to do this question without, you can do. But I think this is a really tricky question to do without a Venn diagram. So it says that they picked 2 activities. It was either painting, which I'll put as a P, and sport, which I'll put as an S. So let's start filling in the information it gives us. So 11 picked painting and sport. So that will go in the middle, because that is painting and sport. And 11 didn't pick painting or sport, so they can sit on the outside. Now here's the problem. It says twice as many people picked sport than painting as one of their activities. So it's saying that the total number in, and let's just show it, the total number in the sport circle is twice as big as the total number in the painting circle. Now, what we can do is we can say, okay, so if the painting we label as X, then the sport will be 2X. But if you look, we've already got a number already in the sport, that 11 there. So in algebra, this will be 2x, take away the 11 that we already know about. And the painting is the same. We know the whole thing is x. So what we're going to do is we're just going to take away the bit we know there, which is the 11, and it will be x minus 11. Now we know that there are 66 students in total. So what we can do now is add up all of the parts of the Venn diagram and get it equal to 66. So x minus 11 plus 11 plus 2x minus 11 plus 11, and all of that will equal 66. This is going to be some solving, so we're just going to put our lines in. Now here we've got x plus 2x, which is 3x. And if I put my tool right, there we are. And we've got minus 11 plus 11, minus 11 plus 11. Well, those just cancel out. So we're left with just the 3x equals, and then 66. We're going to divide that 3 both sides. So we've got x equals 22. So if we go back to our Venn diagram now, we can fill in the blanks. So instead of x minus 11 there, we've got 22 take away 11, which is just 11. Instead of 2x minus 11 there, we've got 22 times 2, which is 44, take away 11, which will be 33. So it says, find the amount that picked sport and not painting, which is this 33 here. There's a lot going on with this question, so what I'm going to do is I'm going to put in all of the time signs that we don't normally show. So we've got 10 times 12x times y to the power 4 times 13 times x to the power 4 times y to the power 4. And I'm going to reorder these to put the numbers together, first of all. And with multiplying, it doesn't matter which way around you do it, so I'm not changing anything. I'm going to put the x's together. And I'm going to put the y's together. So, first thing to do is 9 times 13, which is just 117. Then we've got x to the power of 12 times x to the power of 4. Now we know when we multiply two powers of the same base, and the base is x on both of those, we just add the powers. So it's 12 plus 4, which is 16. So it'll be x to the power of 16. And then y to the power of 4 times y to the power of 4, we just add them together, so it's y to the power of 8. So vectors are shown with how far right at the top and how far up at the bottom. So we've got -3 right, which is actually going to be 3 left, and -2 up, which is actually going to be 2 down. So to start this off, what we're going to do is just put a point anywhere on this grid, and we're going to go 3 right, so 1, 2, 3, and we're going to go 2 down, so 1, 2. Let's show that point there. And then all we need to do is join up these 2 points with a straight line. And we need a direction. So we actually started at the top right one and went to the bottom left one. So the direction is going to be this. And it says it's vector A. So we're just going to label it with an A. To add column vectors, all we need to do is add the tops and add the bottoms. So 3 plus 7 is 10, and 4 plus minus, or just 4 minus 5, is -1. So our answer is 10 minus 1. So to draw a box plot, we need 5 points. We need the lowest point, lower quartile, median, upper quartile, and highest point. Now we already have the lowest and highest points, so we can put those onto our box plot now. So the lowest point is at 0 and the highest point is at 30, as we can see on the cumulative frequency graph. So we need to now find out where the median is. Now the graph goes up to 20, the actual line goes up to 20, so the median we're going to find at 10. We're just going to draw a line across and down, and that looks like it is 17. So our median will be at 17. So we're just going to draw a line at 17. Get it just perfect. There we are. Okay, next thing we're going to look for the lower quartile. So if the median we drew a line across at 10, the lower quartile would do it at 5, which will be here. So that's at 12. So we're just going to draw a line up from 12. Fill in this box, and we can actually fill it in with the lowest point. And lastly, we need our upper quartile, and we do that by adding the 5 and the 10 together to make 15. So we'll draw a line across from 15 and down, and that's 23. So a line up from 23. Try and get this as nicely as I can. I need to move that line a little bit. Oops. There we go, and let's fill in the last bit, join it up with the highest point, and there's our box plot. Okay, so the first thing we're going to do is multiply the coefficient of the x squared and the number at the end, so 2 times 12, which is 24, and 24 is our target number. And then what I mean by that is that we're looking for 2 numbers that multiply together to make 24. But we're also looking for 2 numbers that add together to make the coefficient of the x, which is 11. And that's our objective now. So looking at that, they add together to make a positive, and they multiply together to make a positive. So we know that they are both going to be positive numbers. And so something we can do, if we're not quite sure what the numbers are, is just write out the factors of 24. And we've just got to focus on the positive ones. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. If I do any more, it will just repeat themselves. And then what I'm going to do is just add them together to find out which one gives us 11. And we can see here that the 3 plus the 8 will give us the 11. So we know they're going to be 3 and 8. Okay. So the next thing I'm going to do is just rewrite the question. But instead of 11x, I'm going to split that 11x up into the plus 3x plus 8x. I've just split it up into 3x and 8x, which actually equals 11, so I haven't changed the question at all. Now we're going to be looking at the 2 sections of our expression separately, and we're going to factorise them linearly. So I'm going to just put a single bracket here. 2x squared plus 3x, well, it's only an x I can divide out of both of them, which will leave a 2x plus 3 on the inside here. Looking at the next one, 8x plus 12x. Well, actually I can divide out 4 from both of them, so it would be plus 4 brackets, and it would be 2x plus 3. Now notice something, that the bracket here and the bracket here are equal. If they're not equal, you've made a mistake somewhere. So we can write that down, 2x plus 3. And then for the first bracket, it's just the bits on the outside, you put them together, so x plus 4. So our answer is x plus 4 in the first bracket and 2x plus 3 in the second bracket. And actually the brackets could be the other way around, so you might choose to put the 2x plus 3 first, then the x plus 4. So I'm going to just write out this formula again. 8t plus ut. Now we want to get t as the subject, so the first thing I'm going to do is I'm going to factorise the t's, so t bracket 8 plus u, and what I want to do is I want to get rid of that bracket there, and so what I'm going to do is divide both sides by that bracket, and so we're going to end up with s over 8 plus u equals t. So t is s over 8 plus u, or s over u plus 8. The first thing to notice is that 125 is 5 cubed, so instead of 1 over 125 it would be 1 over 5 cubed. And we know that when you have a negative power, it actually turns into the reciprocal of that number. So 5 to the power of minus 3 becomes 1 over 5 to the power of 3. So n is going to be this minus 3. So we're told in the question that y is inversely proportional to the cube of x. So we can show that by y is proportional, there's proportionality, inversely, which would be 1 over the cube of x. Now to convert that alpha, the proportionality symbol, into an equals, we need to introduce a constant to the right hand side. So we get y equals k over x cubed, and all I've done to the right hand side is multiplied it by k. Okay, now we need an instance where we know what y is when x is something, and here we do have that, or it should be the other way around. What y is, well, yeah, what y is when x is something. So we've got y is 10 and x is 7. So we're going to feed those numbers into this kind of equation that we've made. So it's going to be 10 equals k over 7 cubed, or 10 equals k over 343. Okay. And then we're going to multiply both sides by the 343. So times by 343 both sides to find out what k is. And I'm just going to swap them around just to give myself a bit more space. And we're going to have k on the left hand side here. So that would be 3,430. So k is 3,430. So what I'm going to do is just rewrite this equation here. But we know what k is now, so it's y equals 3,430 over x cubed. And that actually is our answer. I'm going to start by getting x equal to the 0.847 recurring. And I'm just going to show that with 3 dots. And we want to bring forward everything that's not part of the recurring pattern. So what I'm going to do is I'm going to find out what 10x is, and that's going to be 8.4747. So what I've done is I've just got the recurring pattern after the decimal point. And what I want to do now is bring forward one of the occurrences of the recurring pattern, so the 4 and the 7, just one of them. So we're going to times it by 1,000. We'll find out 1,000x, and so it'd be 847.4747, etc., etc. Next, I'm going to take away everything. So 1,000x take away 10x, and that's going to be 990x, and then 847.4747, etc. Take away 8.4747, etc. It's just going to be the same as 847 take away 8, because the recurring stuff will just cancel each other out. So 847 take away 8 is 839. And now I'm just going to put my lines in. And so what I'm going to do now is just divide both sides by 990. And so on the left hand side we've got x, and on the right hand side we have 839 divided by or over 990. So as a fraction it's going to be 839 over 990. So if the area of the rectangle is 10 and one of the lengths is root 75, to find the other length we do the area divided by the length given, and that will work out what the other length is. Root 75 though is something that can be simplified, so let's simplify that. And it's root 25 root 3, so it's 5 root 3. So this equals 10 over 5 root 3. Now notice top and bottom can be simplified, so that becomes 2 over root 3. And we're asked to rationalise the denominator, so we're going to times this by root 3 over root 3. And so we end up with 2 root 3 over 3. So our answer is 2 root 3 over 3. First thing I notice is that this root 125 can be simplified. So root 125 is just root 25 times root 5, which is 5 root 5. So if we write this out, 47 over root 5 plus 15 over 5 root 5. Something else we notice is we can actually simplify the second fraction. So divide top and bottom by 5, so we're left with 3. Now here, because we've got the same denominators, we can just add these. So 47 plus 3, which is 50. And notice the a root 5 isn't in a fraction, so we're going to have to rationalise the denominators, which means we're going to times top and bottom by the surd at the bottom. And so we end up with 50 root 5 over 5. And we can actually simplify this to divide top and bottom by 5, so we end up with 10, and it's all over 1. So A is therefore 10. So we're going to just quickly write out our sequence, so 9, 22, 41, 66 and 97, and we're going to find the differences of each of them. So that's going to be plus 13, then we've got plus 19. So they're different already, we know that it's not a linear sequence, and that's going to be plus 31. So we now look at the difference of the differences, and so we've got plus 6 again, and plus 6 again. When you have a difference of differences, it's going to be a quadratic sequence, and we're interested in what the difference of differences is, because what we now do is get that 6 and we always halve it, and it gives us 3. Now that 3 is actually really important because that is the coefficient of the n squared. So we know our sequence will begin 3n squared. So we're going to do a table now to see what the rest of the sequence will be. And we're going to have our term number and our sequence. So term numbers will just be first, second, third, fourth and fifth. So 1, 2, 3, 4, 5. The sequence is just 9, 22, 41, 66 and 97. Now we know that 3n squared is part of our sequence. So what we're doing now is just removing the 3n squared bit and see what we have left over. So we're going to do 3 times 1 squared, which will be 3, 3 times 2 squared, which will be 12, and then 3 times 3 squared, 27, 3 times 4 squared, 48, 3 times 5 squared, 75. And we're just going to remove that from our sequence. So we've got our sequence, and we're removing the 3n squared bit, because we know what that is. We've already answered that part. So 9 take away 3 is 6. 22 take away 12 is 10. So they're not the same with this. 14, 18, 22. Now, what do you notice? Well, we notice that these ones here are going up in 4s. So we've got a linear sequence here. So they're going up in 4s. So we know that that will be plus 4n. And then we find the 0th term. So we go back. So 6 take away 4, which will be 2. So it's going to be 4n plus 2. So our total quadratic sequence will be 3n squared plus 4n plus 2. A normal sine wave starts at 0, goes up to 1 at 90, down to 0 at 180, down to minus 1 at 270, and then back up to 0 at 360. But here we're given a plus 45 inside the function. Now, a plus 45 actually does the opposite of what you think. You would think that it would move it right 45, but it doesn't. It moves it left 45. So each of these points we're going to move to the left by 45 degrees. So instead of at 91, this is now going to be at 45, 1. And each of these are just going to move left 45 degrees. Now 45 degrees is 2 squares. So it's just 2 squares worth of moving left. And so we get a really horrible start to this because we don't really know where it's going to start. It's going to start somewhere there. And then we've got a nice U shape and then down to here. These types of graph are not the easiest to do because they're stretched out, but make sure you have a U shape at the bottom there. And then we kind of guess here that it's going to go somewhere there. Here we've got a cubic graph and we're asked to find out what the equation would be if it was in this form here. So first of all, notice that we've got a negative cubic. A positive cubic looks like this. So we've got a negative cubic, and there is a minus sign there that just deals with that. So we don't need to worry about the fact it's a negative cubic, because that minus sign just means it's negative, fine. Next thing we want to do is find the roots. So the roots are where the line crosses or touches the x-axis. So here we can see it touches it at 6, so when x equals 6. And here, now this is an interesting one, it actually touches it twice. Touches it at minus 7 the first time going down, and then it touches it at minus 7 going up. So there's technically 2 roots there, sort of one root, but it counts twice because it's going down on one root and then up on the other root. So with these, what we need to do is we need to make sure that at x equals 6 and x equals 7, minus 7, that this equation, the whole thing equals 0. So, if we imagine A, what does A have to be to make this whole thing equal 0 when we look at this, the fact that a root is at 6? Well, if we put A at minus 6, we get x minus 6 in that bracket there. And if we put in the value of 6, then it's 6 minus 6, which is 0, and so the whole thing is 0, because anything times 0 is 0. So if A is minus 6, let's have a look at B. So what does B have to be? Well, if that's minus 7, if we put B as plus 7, then when we substitute in this minus 7 here into the x, we get minus 7 plus 7, which is 0. So if B is minus 7, then the whole, plus 7, then the whole thing will be 0 at x equals minus 7. And for the C, we're looking at that last root. Again, it'll be the same, won't it? It'll be x plus 7. Now, you might ask the question, how do you know which is A, which is B, which is C? Actually, it doesn't matter. We could put A at minus 6 and A at 7 and B at minus 6 and C at 7. As long as one of these is minus 6, 1 and 2 of these are 7, you'll always get the right answer. So I'm going to first of all just draw out the diagram a bit bigger, just so we've got a bit more space. And we're looking at going from B to M, and M is about here. Now the first thing to notice with M, I'm just going to quickly label the other parts on, is that the ratio of A to M is 1 and M to C is 4. So the ratio is 1 to 4 between the two. And what is really helpful sometimes is just to label in the kind of section. So if A to M is one section, we've got 4 of the sections from M to C. So just put little notches there to show the 4 sections. And we can see straight away that A to M is 1/5 of that distance. And that's why it's a nice, easy way to show that A to M is 1/5 of that distance. And let's just put a nicer 5, there we go. And so we're looking at going from B to M, but we can't go directly from B to M. We've got to go from B to A to M, and that's going to be the direction of travel. Now, we don't know the name of the road between A and M. In fact, we don't know the name of the road between A and C. We've got to first of all work out what that's called. So what we're going to do is we're going to go from A to C by going down here and then up here. So we can find out A to C is going to be going backwards down A, then up B. Now A to M is going to be 1/5 of A to C. Now, if A to C is minus A plus B, that means A to M is going to be minus 1/5 A plus 1/5 B. Now we're asked for the vector B to M. And we know that that's going to be B to A plus A to M. We know B to A because it's labelled, it's just A. And we know A to M because we've worked it out down here. And it should be minus, let's get rid of that, because we know it's going to be minus 1/5 A plus 1/5 B. And so A minus 1/5 A is going to be 4/5 A, and then we've got the 1/5 B, so it's going to be 4/5 A plus 1/5 B. Here we've got a half on the outside, so our function's been multiplied by half, and all that's going to do is it's going to halve each of the y coordinates. So we've got a y coordinate here, and half of 6 will be 3. The 3 we've got here will be 1.5. The bottom of the curve here will be at 1. And you just go through and just halve all of the points on the graph. And when you do that, you should be able to draw in the graph, and it should look something like this. We'll try our best to draw it. And we're not looking for it to be absolutely perfect, but looking at that, you can clearly see that all of the y coordinates have been halved. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.